Welcome. Welcome to Meet the Scientists. I'm Reide Corbett. I'll be your host here at the Coastal Studies Institute. Tonight we have a special guest, Dr. Sid Narayan. But before that, I wanted to make a couple announcements. And so CSI will be hosting summer camps again this summer. We actually have 8 weeks of summer camps between June 20th and August 19th. We have 4 different themes this summer. And so check out our website. We will go live with registering for summer camps starting March 1st. The second announcement is CSI will be hosting the 2022 North Carolina Renewable Energy Challenge this year. It will be hosted here at the Coastal Studies Institute on April 30th. There are 2 different divisions for middle school and high schoolers, and you can focus on either wind energy or water energy. So get your teams together. There's cash prizes. Did I mention that there's cash prizes? So more information can be found on our website. Register your team, get involved. Again, April 30th is when the competition takes place. And the winner here could go on to the national challenge. So take the opportunity. It'll be a fun event. And so for that, I think what I'll do is introduce again our guest tonight, Dr. Sid Narayan. Sid is an assistant professor in the Department of Coastal Studies and has been with us since January of 2020. So 2 years, 2 pandemic years, which makes it challenging but exciting. And Sid has a really interesting background. Sid's a coastal engineer, civil and coastal engineer, and Sid, you've got as much experience on different continents, which I find really interesting. And so I think, maybe we'll just start with you introducing yourself. What I find really exciting and interesting is your education from undergraduate through PhD involves multiple continents, which gives you a really interesting background and a lot of interesting experiences. But maybe just sort of start with that. It's a lot. But start with that as an introduction, and maybe you can sort of give a little bit about your background, your interest in engineering, and maybe what brought you here to the Coastal Studies Institute.
Sure. Thank you.
Yeah.
Thanks, Reid. Yeah, absolutely. I think it's been a very global experience, and I'm really lucky to have had that. I come from southern India, from Chennai, big coastal city. I say I grew up on the coast, but it's not technically true. It takes quite a while to get to the coast in traffic. But it's
like us in the summer.
Yes.
Not quite. Not quite.
Yeah. So I did engineering in India. I did my civil engineering in the city I grew up in, Chennai, and then I came to Europe to do a traveling Erasmus Mundus Masters on coastal engineering and management, and that took me a semester in each country to Norway, the Netherlands, and the UK. And I ended up doing my master's thesis at TU Delft in the Netherlands. And then after that, went back to the UK for my PhD in Southampton, and then hopped over the Atlantic to the US here for my postdocs in California, Santa Barbara and Santa Cruz, and now I'm here since 2020.
Those were actually a lot of surfing communities.
Yes.
In Santa Barbara, Santa Cruz, and now the Outer Banks.
Yes, and Southampton as well.
Southampton, that's true. And so, so there's a common interest there, maybe. And so your interest is in engineering, and coastal engineering specifically. And I'm curious if growing up in sort of a coastal community, a much larger community than the Outer Banks, did that sort of lead you down this path of coastal engineering? And what sort of prompted that interest?
Probably subliminally. Actually, it's funny.
So maybe not.
But it's funny because I tell friends that I actually wanted originally to do journalism, and I like writing, I like languages, and then, as many Indians end up doing, you do engineering or medicine if you want to have a career and a living. So I chose civil engineering because I really like the way different subjects interact and the scale at which things happen. And after that, I knew I wanted to do something in water because I had a lot of really good teachers in water resources and hydrography, and I was introduced to the coast as a subject. And I was talking to some professors in India as well who then put me on to coastal engineering, which I had never even known that coastal engineering is a subject.
Right.
And I looked at the syllabus, this was for the masters in Europe, and it fascinated me because it's precisely why I also chose civil engineering, because there's so many things going on. It's land and water and all kinds of things interacting. And looking at all of that from an engineering background, from an engineering perspective, it seemed fascinating to me. So I went ahead, did that master's, and since then I haven't looked back.
It's interesting how one subject, one person, right, a comment could sort of steer, in this case, your entire career path.
Yes.
And so it is, those little things can make a difference as you're sort of thinking about careers and where the direction that your career might go. And so maybe describe what coastal engineering is from your perspective and how that fits in with civil engineering.
So coastal engineering is essentially managing whatever happens on the coastline. So understanding and managing all the sorts of processes that happen on the coastline in terms of, for example, how does sand move? And what happens when my tides come in and out? What happens when on top of those tides I have waves or storm surges? So you can think, and this encompasses so many things, like you can think back to ancient ports where they had to manage tidal flows in order to figure out how to get ships in and out.
Sure.
That's coastal engineering, and it's civil engineering because it's, you're building and you're managing, you're building artificial structures, you're managing natural processes.
Right.
And so that sort of encompasses all of those. You take all of these knowledge of coastal processes and then look at how we can handle those processes, manage those processes to the benefit of human beings. And interestingly, I also have, just in my family and personally, I have a passion for the environment, for making sure that we handle our environment carefully, sustainably.
Right.
And that is an angle that also interested me about the coast. Even though I come at it from an engineering perspective, the coast is inherently a place where you have so many natural ecosystems. And so understanding their role and their function and their processes is also an integral part of that. So it can be really anything.
Right. It's fairly broad, integrating
Very broad,
the natural environment, built environment, people,
Yes.
all of it. And so that's sort of a fairly broad 30,000-foot view. Maybe focus a bit, give us an understanding of what your research, where your interests lie within this broad area of coastal engineering.
Sure, yeah. So a lot of the work that I look at is understanding how people on coastlines face and deal with hazards. And so living on the coastline is great, but then you also have storms, you have high waves, and you have people who need to manage those hazards, adapt to those hazards, and continue living there. And a lot of my work has focused on methods and ways with which we can help people adapt to coastal hazards. And this is especially relevant, now that sea level rise rates are accelerating globally. You have land subsidence in many coastal cities while people keep moving to the coast. And so there are people who are putting themselves at risk while that risk is increasing.
So in thinking about coastal engineering, and you just mentioned a couple words there that maybe I want to pick apart a little bit. So adaptation, and one you had, I don't know if you mentioned it yet or not, but I want to bring up is resilience. And I wonder from your perspective as an engineer and sort of the work that you're doing in the way of adaptation, I wonder if you could sort of give us maybe your definition and how you approach those two words, adaptation and resilience, in your work.
Let's start with adaptation, the easier one. So adaptation is essentially how we respond to change and how we respond to change in a way that allows us to continue our ways of life or our whatever is important to us. And so again, coastal change, sea level rise, how do we adapt to that? Resilience is a bit more complicated because it can refer to so many different aspects of both the human and the natural system, but just focusing on the human system, it's essentially our ability to both withstand but also recover from shocks or from chronic pressures.
So shocks like a hurricane or
Shocks
some
like
sort of
that.
event.
Yes,
Right.
yeah. And also, if necessary, find a new stable state. Going back to the very original definition, that derived from ecology is, sometimes we may not be rebuilding, we may be doing something completely different. And that can also be an aspect of resilience, I think.
So one aspect of your work and some of your papers that have really taken off, I think, of late are focused on nature-based adaptation methods. So I wonder if you might speak to what that is and maybe give some examples from your own work.
Sure, yeah. So that's again sort of, I had this passion for nature and for conservation, and my path down this whole topic of nature-based adaptation. So before that, nature-based adaptation, essentially what we mean is we are trying to understand, where we have natural ecosystems or where we can restore natural ecosystems to what they once used to be. Can we do that in a way that actually helps us by reducing the risks that we face from hazards like storms and waves, and can that help us in turn adapt to coastal change? So essentially, protecting nature to protect people. Mm-hmm. And that's sort of a very brief way of summarizing that. And it was, during my master's, I was looking for a topic to do my master's dissertation on, and I knew I wanted to do something around mangroves, coastal engineering and mangroves. And I sort of had this vague idea in my head, and I was talking to my supervisor again, and we were literally looking at a map of India. I was in the Netherlands, but we were looking at a map of India, and we both sort of chanced across this place where there was this mangrove island, and behind it there was a port that was being developed. Mm-hmm. And we sort of had this aha moment of, hey, there seems to be a case here where your mangroves might be affording protection to something human, some human infrastructure, because this place has storms, it has an island, has a port. And so why not look into that? And so I sort of developed that and worked on that, and that work has, I think, started me off on this path of inquiry of, where and how do ecosystems help reduce risks, and where they do help reduce risks, how do we go about managing those ecosystems and making sure that they work for us?
And so, thinking about that, so that gives a good overview of some of the work that you're doing and some of your interest. How do you approach your work? And before I get into that, if anybody has questions, don't forget to type those into the chat, and I'll be happy to drill Dr. Narayan with your questions beyond my own. So anyway, so thinking about the tools that you use, your approach to this better understanding and development and thinking about coastal engineering.
Sure, yes. So most of my tools are in the lab on computers. So a lot of my work is using numerical and empirical models, simulations, to understand essentially how these ecosystems, so these are basically structures and vegetation that sit in water. They sit on the coast, either in the intertidal if they're wetlands, or offshore if they're reefs. And how do these structures and vegetation interact with my water levels? How do they interact with my waves? How do they interact with my storm surge as it propagates on shore? And so understanding those interactions, understanding how those interactions then influence flooding. So for example, how does flooding look like if I have wetlands in front versus if I don't have wetlands in front? For example, flooding from Hurricane Sandy or Hurricane Ike.
Right.
And knowing that difference, then actually integrating that with completely different data sets. So data sets on socioeconomic exposure. So where do people live? What assets are located here? Tying those to then understand what is the physical and the economic value of these ecosystems in reducing those damages.
So that's an interesting thing for an engineer to bring up, is the economic value, right? So what role does that play in your own work? One of the things I think that we do really well here at the Coastal Studies Institute is trying to integrate across disciplines. But I'm curious, as an engineer, who are you working with, and what aspects of this this approach do you deal with versus some of your colleagues, and how does that interaction work? Again, bringing this idea of the economic value into
Yeah, absolutely. I think when you asked about tools and technology, I was going to say one of the tools are the computers in the lab, but the other tool is collaboration.
Right.
And it's really, really, really essential because I can do my numerical models of how vegetation influences water levels and waves and flood extents. But in order to then go a step further and say, this is what the value of that physical role is for these ecosystems, and that's what that means for conservation, I need to be talking to economists and also using secondary economic data sets. So for example, some of the collaborations that was still ongoing are with the risk insurance industry. Mm-hmm. So some of my work is working with catastrophe risk modelers who do basically the same thing. They look at the physical catastrophe side of things. They also look at the exposure side of things, the economic value side of things, and integrating those. And coastal engineers do go a little bit there. So for example, we have this concept of what we call damage functions. So understanding, for example, different building types, you have different water levels of flooding, what percentage of your structure does that damage? And then you add an economic value to that. So that kind of using those secondary data sets, using those methods, and working with economists to understand things like benefits and costs and cost effectiveness and all of those economic tools as well, bringing all of that in. So when we start bringing all of the economic tools and analyses in, I defer to my economic colleagues.
Right.
And the other is a lot of my collaborations are with ecologists who also speak a completely different language. And that's understanding, where do these ecosystems sit in the first place? What influences the structure of these ecosystems, which then influences their interaction with the water? And how does that change? And what are the implications of those changes? So that's, again, collaborating with ecologists to understand and bring that into our models.
And so my next question is sort of focused on the challenges within your own discipline. But I wonder if maybe you can incorporate, thinking about these interdisciplinary interactions that you have, how you bring their understanding of the physical environment into your numerical models. And is that sort of a two-way information highway such that you develop a model, but you learn something from your colleagues, and then you sort of rethink your own model and try to bring some of what their understanding of that environment into what you're doing. And so is it iterative as you move forward? And maybe, what are some of the other challenges that you face within your work? You sort of mentioned these different databases. I imagine much of your work is going to be dependent on how much data you can get or how good that data might be.
Yes, data is a big challenge because that informs the quality of the models. Of course, you have, with increasing computational power, we have better and faster models. You can reduce grid resolution. But then if your data, for example, on exposure, so what are the economic values in this place, how many buildings are in this place, that data is actually really hard to get sometimes, especially at your local scales. And so unearthing that data is difficult, especially if you're working across the globe. The US generally tends to be data rich compared to many other geographies. And the other is also just very what we would think are very simple questions, like what is the current extent of coastal marshes? Mm-hmm. And that question is actually something that's really difficult to answer.
Yeah, whether it's on a state or country or global, right?
Yes.
Yeah.
And so that is, you would think that's a simple question, right? But then when we start putting that data into our models, we're like, wait a minute, this data is actually from like 10 years ago, and that patch is from 5 years ago, so we need to start making assumptions and do the best we can. Right. So that's one challenge in terms of just, having these coverage issues, and that's greatly improving as well with work that people here are doing as well, right, and elsewhere. And the other challenge is also, so far I haven't really looked at future changes. So far, most of my work has been focused on the past. Haven't really looked at what is going to happen with sea level rise and with climate change. And that is a huge challenge where it has to be a two-way interaction with the ecologists, right, where I'm like, hey, look, our models are showing sensitivity to flooding, for example, for these kinds of changes in ecosystems. How realistic are those changes? What if we need to build future scenarios of ecosystem change, what will that even look like?
So I wonder, so you mentioned that a lot of the work that you've been doing and have done is focused on the past. And so in what respect do you mean? And so trying to understand different storms and the impact they've had, or trying to provide information on what could have been done differently for less damage?
Mostly,
And I'm curious how that informs looking forward.
Yes. Yeah. So mostly, I think this has been looking at how, for past hazards and for past storms, have ecosystems helped protect us.
Ah, okay.
So, for example, Hurricane Sandy. Hurricane Sandy happened in 2012. We had wetlands at that time across the northeast of the U.S. What did those wetlands do to protect us from flood damages? And we do that pretty simplistically, actually. It's basically, again, scenarios where you have what you actually have, Hurricane Sandy and the wetlands, and then you say, okay, imagine all these wetlands were lost. Imagine we had just not cared about them, or there was a destruction event, and all of that
we
became
paved them all
water.
over.
Yeah, exactly. What would have happened?
Right.
And similarly for other geographies and other ecosystems, mangroves in Florida, Hurricane Irma, for example, we're working on right now.
Okay.
And what we're doing with that is two things. One of them is we're saying, okay, we know that these events happened. We test our models for these flood events. We make sure that our models work. We then put in these scenarios and we just see basically if our models are doing what we would expect them to do. Second, of course, is looking at the past and saying, hey, look, this is proven. This actually happened, and this is the value of these ecosystems. So if you, again, want to be thinking about conserving ecosystems, you can start thinking about where, when, and how.
Right.
And in that way, I think that does help inform the future, both by helping us improve our models, but also by helping us ask the right questions and look, where do we need to look for future
helping
changes.
manage various habitats based on what you learn from that, and which certainly plays into the economic value of the habitat. And so I think that should always play a role. People, I think, myself included, right? We understand dollars and making that connection so it's not sort of this abstract idea that wetlands are important, but actually you can monetize that in many cases.
Yes, absolutely. I mean, it's
There's
not
assumptions associated with it, sure, but
yes. I mean, it's ideally, we would like to have conservation for conservation's sake, but
Sure.
ultimately, a lot of things do come down to money and to monetizing these values, and the whole concept of ecosystem services is exactly that, right? It's just basically saying, we can put a dollar value on this, or we can put whatever monetary value on this.
yeah.
The danger, of course, is that we miss out what cannot be monetized and what cannot be quantified in that way. And things like, for example, nature-based solutions are fascinating and they work, and I always end my talk with this sort of a bit of a wet blanket where I'm like, they are never going to be the only solution. They are hardly ever going to be the only solution, and they are only going to be one part of many different things that we need to do, and they may not even be the right solution for a particular place. Depends on a lot of things.
Right. And so a lot of your focus has been, again, nature-based solutions to challenges moving forward. I wonder if you couldn't speak to some of your work. So I know you've got multiple projects going on, but you have some local stuff, right, within North Carolina, and in fact, collaborations within ECU and elsewhere. I'm curious if maybe you just speak to that and maybe what informed some of that work to get it started here in North Carolina. I mean, again, sorry, I keep interrupting. You're coming from this incredible background from all over the world. We placed you here, you came here to North Carolina, and you are getting work started locally. And so from that context, how about that?
I think from the time I came here to the Outer Banks, I have been joking to people saying, I used to study hurricanes from a safe distance. And it's just like, I mean, I am literally living where I do my work.
That's right.
It cannot be more.
And now it means something personally to you now, for
yes.
sure.
Yeah, so I mean, we're out on the coast here. It's a dynamic coastline. We have a lot of exposure here in terms of people exposed to hazards. It's a hurricane zone. And we have a vast stretches of coastal ecosystems. All of those, the three things that I look for in my work come together here. And on top of that, simply because of where we sit at ECU and on the coastal campus, most of my work here has been started off simply through collaborations both within ECU and other North Carolina universities. And it's these questions, for example, we have working with other ECU faculty, Dr. Gitman, we have, looking at oyster reefs and how oyster reefs can help reduce risks to shorelines by reducing wave energy.
Right.
And we also look at marshes here and also in Texas, salt marsh nourishment, and how if we were able to sustain these marshes over time, what benefits would that provide to landward communities? And so it's, I mean, very relevant place in terms of the people and the environment as well.
And so, I've been involved in a couple of talks or even field excursions where it's been an engineer and myself, more from a coastal processes background. I often feel that people are staking us against each other, right? The engineer versus, quote, the scientist, right? Which I think is unfair. I think, there's a lot of great collaboration that takes place between a physical scientist, somebody that's focused on the ecology, and engineers. And along those lines, and thinking about some of your work, where do you see some of the challenges in your field, and sort of including the challenges that we likely face with climate change, sea level rise? Where do you see some of your work going and the challenges faced within your field?
Good question. I was actually thinking that today it's probably meet the engineer, not meet the scientist.
That's right. Yeah.
And I think the difference is, or at least traditionally, I think the differences are being blurred, because I am an engineer by training, but I am an academic engineer.
Sure.
And so there is that difference. And so I think traditionally the difference simply was that scientists are interested in processes, engineers need to make assumptions to build things to keep people safe. And we take the understanding of those processes, add our assumptions and our safety factors to them, build it twice the size it should be, and then we're happy. And it's sort of changing, especially within engineering. This whole idea of nature-based solutions to reduce risk is a massive challenge, because we are suddenly being asked not to say, oh, I'll build a concrete seawall, and I'm just going to add a foot to it and make it twice as wide just to be safe.
Right.
And you're safe, and I'm safe, and I'm good, and no problems. Now we're being asked to look at solutions that are dynamic, that cannot be messed with too much, because if we want to keep that ecosystem, if the whole idea is to conserve these ecosystems and keep them healthy, then we need to allow them to function, allow them to be dynamic, allow them to change states. Marshes look very different between summer and winter. What does that mean for our risk reduction? And so we're also having to deal suddenly with very sort of these concepts of adaptive management, for example. And that, I think, is the biggest challenge for engineers in this particular niche, where trying to be more nimble.
Right. I mean, some of that is, and tell me if I'm taking it too far, is maybe acknowledging that we can't, and again, I don't mean to offend here, that we can't necessarily engineer ourselves out of challenges that we have in the future, that we need to think about, because one of the things your own work is showing you is that, these marshes are critical. And so we can't just build a wall in front of all of these marshes to prevent shorelines from changing. The idea that these marshes are dynamic and require interaction with the water to be sustained moving forward, and the importance of their protection. I'm not sure where my question was there, but the idea that engineers and scientists that we need to work together, right? And that we aren't going to necessarily only focus on an engineering solution to the challenges that we face.
No, definitely, and I think that's the upside for making and sort of getting engineers to look at this is we are used to thinking of just that local problem and basically over-engineering a solution without really bothering about, say, second-order effects or downstream consequences. Mm-hmm. And that is something that we're waking up to now, where we're we've engineered so much of our shoreline, we've done so many beach nourishment projects that papers, other excellent work by other engineers and scientists have started showing that this is having effects far downstream and things that we would not have even thought of. And so working more with natural processes is, we are coming to the realization that we need to work closer with natural processes in order to avoid those second order effects. And this is potentially a really good place to start.
And so we often hope, anyway, that we have a bunch of young potential scientists or engineers or again, I don't know if that's offensive or not when I say scientists and engineers.
I think it's fine.
We hope that there are young audiences looking at this, watching this, and thinking about, oh, that sounds like a really interesting career. How did they get there? And so, again, you've had a really interesting trajectory that have brought you here to ECU. I wonder if there's any advice you might give to, the middle schooler or even, the undergraduate, and how you got to where you are, and what little bits of advice would be helpful to move them forward.
I think probably start with two, might have more as I keep talking,
Sure.
but one is to really be open to talking to other disciplines and thinking about how other disciplines and how other fields look at the same subject. I think having that, being able to have that perspective, have those conversations is increasingly relevant for engineers as well, because we really need to start working with people other than other engineers.
Right.
And I think that's critical. The second, I think, is simply to not hesitate to go and talk to professors or people about what you want to do, even if it's really vague.
Right. They can come talk to you.
Yes. Like, I had no idea that coastal engineering even existed as a subject. I vaguely knew I wanted to do something in water, and I'm so glad I spoke to the professors who put me on this path.
One of the things you just said is, the idea of talking to somebody, for an engineer to talk to other disciplines, to better understand, maybe the environment, how an engineer can incorporate that. I think that goes both ways too, right? Is for somebody that's studying coastal processes, we are faced with significant challenges moving forward. To have a better understanding from an engineering side of what is and isn't possible, and how we can use engineering to help move us in the right direction of better, more resilient coastlines. You worked with a group of scientists recently in the last couple of years and put together one of these, an IPCC chapter, Intergovernmental Panel on Climate Change, focused on sort of coasts and the challenges. I think it's really relevant to the work that you're doing, obviously, but also to coastal communities. I wonder if you might just speak to that a little bit. I know that's putting you on the spot, but sort of what came out of that, and maybe the direction that we're going as a community, a scientific community.
Yeah, sure. I mean, before I start, I'll say, yes, please come talk to the engineers.
Right.
Please do.
Sure.
So the IPCC report that I contributed to was a special report. It was 2019 special report on oceans and cryosphere. And what's the portion that I contributed there specifically was on adaptation.
Right.
And we have, it comes like chapter 4, I think, but it comes behind, in sort of after all of the chapters where you lay out the science.
Right.
You lay out the science, the natural processes, what's happening all around the world in terms of the ice sheets melting, in terms of the oceans warming, what does that mean, air, water, land, in terms of sea level rise. And then after laying out all of that science, we then come to, okay, what do we do about it?
Which is critical, right? I mean, oftentimes we'll talk about all the problems, we never provide solutions or a direction that we might go. And so that's what I thought was really great about this chapter. And sorry, go ahead.
Yeah, no, and I think that's why I like the subject as well, and that's exactly where I see, the scientists understand the processes, and then we take those processes and say, okay, what do we do about it? And then so we, in this chapter, essentially, a number of us lay out the various options by which people can adapt to sea level rise, to the effects of sea level rise, and that includes, say, continuing to build seawalls where it is necessary to do so, maybe building a storm surge barrier where you need to, but then also including this aspect of nature-based adaptation. So where do we have the confidence to be using nature to help us adapt to sea level rise effects?
Yeah, and again, I use figures from that chapter. I think it's a great resource moving forward for us to think about not only presenting the challenges faced, but looking at various solutions, and again, showing in areas here in North Carolina and in our own backyard how we're using some of those today. And I think it's important to recognize that we are adapting, we are creating a more resilient coast. We might be a little bit slower than some communities or some countries in moving in that direction, but here on the Outer Banks and across North Carolina, we are developing more resilient coastlines, and I think it's important that we recognize that and highlight those where we can. And so I think, again, the work you're doing is great. It's important in North Carolina, and even your international work is relevant to what we're doing here in North Carolina. And so I think that a lot of that is really, really exciting work that hopefully will continue.
Yes.
So I wanted to sort of put it back on you before I ask a couple. We've got several questions coming in. Maybe put it back on you for any final statements on. I'll direct you. Sort of focused on the idea of the direction that we're moving in, and challenges with the coast and resilience, and what an engineer's role might be.
We'll take care of everything.
There it is. We'll engineer our way out of it.
Exactly. I think that it's being recognized around the world, but it's also here where we are sitting in North Carolina at ECU and at other institutions in the US, that the challenges we face are complex, and the answers to these challenges are going to be complex and are going to require collaboration across disciplines. And I think that's one thing that I keep thinking about, and I keep hearing as well, is that requires collaboration. One, and probably more challenging, is it is going to require us to think at scales larger than we've been thinking right now. We need to be thinking across administrative boundaries. We need to be thinking at landscape scales.
Right.
We need to be understanding that local, ultimately our solutions need to be based on local context, but we need to realize that those solutions might have large-scale effects. And so, sort of expanding what we do across the disciplines and the people that we talk to and across spatial scales, I think
that's great.
Going to be a challenge.
All right, so I've got multiple questions here.
Oof, okay.
All right, so first, do you see opportunities for coastal protection systems integrated with marine energy harvesting?
Yes, that is something that has actually been studied a little bit. I think oscillating water columns on the shoreline, for example, that sort of, again, in a very concrete structural way, but yes, it is something that can be investigated, where you have your structures or array of structures, for example, that might be reducing wave energy behind them.
All right. Okay, so what might you say or advice you might provide to someone such as a marine contractor who wants to pursue shoreline stabilization to think about a sustainable coast?
I would say that the contractor, plugging my own field, is to consider nature-based options.
Sure, yeah.
Consider them.
This is your opportunity for
yes, exactly.
self-promotion.
It may not be the right thing, but do consider it. And the second is to, I think, consider the effects of whatever that structure are going to be adjacent coastlines, but also looking forward a few years beyond the traditional design lifetime, just to build in that buffer of, especially with sea level rise accelerating in many places.
Yeah, and I think bringing in the economics to that, right?
Yes, absolutely.
Especially when we're dealing with, if it's individual homeowners and things like that, the economics of that life cycle, life.
And one more thing I think on that point, especially with these nature-based solutions, is that often coastal protection is just one of their benefits. They often offer multiple co-benefits, and there are projects where you have multiple owners of a project who receive multiple different benefits from that. Oh. So then your problem of, I need to solve this coastal erosion problem suddenly becomes, can I find a party of people who can implement a solution that actually solves like 3 or 4 problems at the same time?
Right.
Who then put money into it.
Yeah, and thinking beyond maybe just your own property, but thinking of it from a community standpoint.
Yes.
Still questions coming in. What impacts have you observed with mangroves or other natural protection on sediment transport? And are there any considerations to ensure neighbors' coastlines are compatible?
First portion, mangroves, like coastlines with a lot of sediment. They don't perform well in sediment-poor environments. Having said that, they do help locally trap sediments. And so mangroves will influence local sediment transport by simply trapping and building on those. And I mean, there are places where mangroves have been restored, but they've simply failed because there's a lack of sediment from upstream, or because there's subsidence or issues like that. There's a lot of examples of that as well. So
right.
it's a bit of both.
Yeah.
The compatible, I'm not exactly.
Yeah, so the second question is, I don't know that they're related, so are there any considerations to ensure neighbors' coastlines are compatible? I mean, I could see that as maybe somebody that puts up a bulkhead versus you're trying to create nature-based on your own property. And so I'm thinking that's sort of thinking about these parcels of different properties along a coastline.
I think with nature-based solutions, the main thing is to make sure that whatever ecosystem if we are restoring, whatever ecosystem we're restoring is actually appropriate to that place. And so that's where you need to talk to ecologists to find out if that's okay, or if that's something that's the right thing to do. There's a limited extent to which we can influence what the neighbor's shoreline looks like. On the other hand, again, I think Dr. Gitman and other colleagues had a paper out a while ago where there's a neighbor see, neighbor do effect.
Right.
Where if I have a nature-based solution, I might be incentivizing my neighbors to implement a nature-based solution. So you could be the pioneer in your neighborhood.
That's right, be the first, be the first. How do models go from being predictions to solutions?
Oh. Models are not the solution. Models can never be.
But they steer us
yes.
towards a possible solution.
I mean, what models are doing essentially is simplifying the world to the variables that we are interested in so that we can understand how those variables interact with each other for practical purposes. I think that's sort of, ultimately we are interested in a few things and we want to study those things and see what happens if A changes, does something collapse within our model. And in that sense, models can help us make sense of things that we cannot intuitively understand or we cannot observe, for example. I mean, it's even with storm surges and, for example, mangroves reducing water levels during storm surges, there are like probably 2 or 3 field observation studies because those gauges are going to break during a storm.
Right.
So things that we cannot observe, we have to model. And that's where they help us.
And I think in addition to what models allow you to do, I mean, you mentioned things that you can't observe. Once you can model that physical environment, you can add things to that model to see how the environment might change, to help steer potential management solutions.
Scenarios, exactly.
Scenarios, right.
Yeah.
So it's leading to different scenarios. Let's see. Do you see traditional engineering curricula becoming more flexible and making room for more natural science education?
Oh, thank you. Yes.
Not a planted question.
No, absolutely. I think there is also a move in coastal engineering, but probably, I don't know about other engineering fields as well, but in coastal engineering, there's definitely a move to expose engineers to other perspectives and also bring people into the classroom, students into the classroom who are not necessarily engineers but come in with these other perspectives. And it's definitely, I think, traditional engineering curricula are going to start reflecting this as we go forward.
And so it's certainly open. It's a field that's likely expanding moving forward and in need of bright minds.
Yes.
And so with that, it's a great place to sort of thank you. We appreciate the time. We appreciate the knowledge you've shared with us, and we look forward to continuing to work with you. So again, Dr. Narayan from the Department of Coastal Studies. Thanks a lot.
Thank you. This was great. Thank you.
Till next time, appreciate it.